Systems Facing Call. We're excited to host our topic today, which is software installation strategies. And for this topic, we thought it would be best to put together a bit of a panel of experts. And we have the originator of this idea and one of our experts here on the panel, Dori Sajdak from University at Buffalo. We also have Kit Menlove from Idaho National Lab. We have Bart Oldeman from McGill HPC Center, as well as Calcul, Quebec, and the Digital Research Alliance of Canada. Joined by Charles Coulombe, also from Calcul, Quebec, and the Digital Research Alliance of Canada. We are also colleagues up here in the Great North. So we'll kick things off by going through a bit of an introduction. We'll allow our panelists to introduce themselves and provide a light introduction to a perspective of their choice on software installation strategies. So with that, I'll pass it over to Dori to start.
Thank you. Let me get my PowerPoint up here. I'm hoping that I didn't prepare too long of an intro. I'll whip through this though. Let's see. So my name is Dori Sajdak. I am one of the system administrators at the University at Buffalo Center for Computational Research. I just wanted to give you a little bit of information about our center. I would say we're probably like a medium-sized academic HPC center. We've been providing research computing for the University at Buffalo for about 23 or 4 years. We are separate from the central IT, so we kind of run our own silo of infrastructure just for research computing, and we have an on-premise cloud. So we usually have about 1,500 to 2,000 active users at any given time, usually between 350 and 400 research groups. We have a pretty small staff on the operations side. We have our director and another computational scientist, 6 sysadmins, and 2 research computing facilitators, and they're the ones that do really the technical work and the user support. We also have a team that just does software design, so they work specifically on the XDMod NSF project. We have 2 clusters that we support. One is for all academic users at UB, and we also have a separate partition for industry customers that pay to use it. And then we have a faculty cluster that we use for when faculty want to purchase their own compute nodes, they'll get their own partition in that cluster, and then they can run, their groups can run on that as needed. Total, we have about 1,100 compute nodes right now, a couple login and compile nodes, and those are all accessed either through SSH or open on demand. So just as a little bit of history, between 2019 and 2021, we lost about half of our staff. We were not allowed to replace any of them, and there were a few reasons for that, one being COVID, but more so it was a huge group of them went to a different institution. And we lost about 15 years of institutional knowledge with that group of people when they left. So at the time, we decided we really needed a better way to manage our software installations, because at the time, really one person was doing all of that. We didn't know what she was doing, and then she left and kind of we were in a hole there. So we wanted to make sure that we could spread the work across all the technical people, but none of us are experts in these different software packages. So we needed to spread the work out amongst everybody. We wanted to automate whatever we could. We wanted to support the different architectures within our very heterogeneous clusters a bit better than we were before. And then we also wanted to set up a framework that our users could make use of as well. So we ended up modeling our new software environment on what was Compute Canada at the time, and the European environment for scientific software installations, I think it is, EASY. So we have a Gen 2 compatibility layer. We use EasyBuild for installations, which generates the LMOD modules, and then we publish all of that to a CVMFS repository. So I know that's a lot of technical stuff, but that's our framework. So it took us probably a good year of researching and testing all of that, and then another year to roll that out to our customers and get them off of the old 20-plus-year-old software stack that we had. So after that rollout, we spent probably another year or so. I feel like it hasn't been that long, but I think it has. Basically installing anything our users asked for, as long as there was an easy build recipe available that we could at least modify it and get working. But what's come up recently as we go to put out a new software environment for this year is that we are struggling a little bit with any codes that are GPU enabled. They're If you look at PyTorch, I think it's updated at least monthly. There are a lot of hoops to jump through to get those to install correctly with Easy Build, at least in our environment. We have a lot of bioinformatics researchers, and they like lots of different tools. So they might be smaller packages, but they could want hundreds of them. Some of those or many of those are outdated. We run into installation issues with them that we have to kind of go down into the weeds and try to troubleshoot. And we also have this concept of like, if I can request the software, they'll just install it for me, even if they've never used it. They have no example of how they might use it with a data set we could test against. So we get a lot of requests where it's just kind of, we just want to test it. So that was a heavy load on our staff. So back in January of this year, we decided to revamp our software policy, and I did include a link. It's quite lengthy now, but if you wanted to take a look at it, we pulled from sources all over the place. We were just Googling around for academic HPC centers and software policies. So a lot of that is from other organizations. But we decided, rather than be ambiguous, and basically before we were saying, if the software works on Linux, we'll try to install it for you, or if the software is available with Easy Build, we'll try to install it for you. We clarified some of our wording. We have some minimum requirements. Basically, we're not going to install something that's 10 years old and hasn't had any updates. We added a security requirement. Even if it is a little ambiguous, at least there's something in there that's saying it has to be actively supported software. In fact, I got a request this morning for something that was last updated in 2012 and requires Python 2. So that was an easy no. But sometimes these packages are important to users, so we have to figure out a way to help them use them. As far as our requests go, we have been using a GitHub repository. We updated that, so now we use some issue templates to gather some more information about the request, like besides what research group are you part of? Do you know any other research groups that would want to use the software? And then we ask our users to go into GitHub and like the requests that others have put in, so that we can have some sort of priority, knowing, okay, there's a bunch of people that really want this, so we're going to bump that up to the top of the list. We do have licensing restrictions, so it has to be free to use in the academic environment, and then anything that's licensed, or even that you have to agree to, you have to log in and register and agree, even if it's free. We tell the groups that they have to install that themselves in their project directory. And then we said no to GUIs for the most part, which we'll be talking a little bit about later. So that's our external policy. Our internal policy, this is where things start getting dicey, and this is why I asked if we could put together a panel on this, because it really has nothing to do with the technology or the framework on how we're building software, but it's more like, how do we decide what we can possibly support? So to start out with, we decided for our next software environment, we're going to use Easy Build mainly only for compilers and tool chains, any base software that's required by other packages, because we did get kind of out of control with just installing everything over the last like year and a half or so. anything that was available and easy build that people asked for, we just installed it. And now we're having trouble with keeping those up to date. And we're also, as we move on to the next software environment, we're wondering how many of those applications are even being used anymore, and should we put a newer version of that application in the new software environment? We have told our users now, if they're using anything GPU enabled, we recommend the NVIDIA containers for those. We've put a lot of work into updating our documentation, and we even built a whole class in our CMS for how to use Python at CCR, so that they learn how to either use virtual environments or containers. For a while, we weren't supporting Anaconda at all, but now we've provided them an example of how to use it in a container. So these are just kind of some of the concerns that we have going forward. And then basically, we really need to understand better how our users are using the software and how we can test it once we install it without investing a ton of time into learning software that we're not actually going to use. So I'll stop there.
Yeah, thanks so much, Dori, for that thorough introduction. Really appreciate it. So with that, maybe I'll pass it over to Bart for your introduction. And not
Okay,
sure how you want to partner with
I'm going to
Charles, but
share as well.
yeah.
Oh, I need to send a request to share.
Oh, there it should be enabled now.
Okay. Okay, there we go. Share. Okay, so you can see my share now?
Yeah, it's coming in
Okay,
perfect.
great. Yes, so hello, pleased to meet you. I'm Bart Oldeman. I'm a software installation coordinator at the Digital Research Alliance of Canada. And as it's organized, I am then a member of the Research Support National Team with some other people. It's about a team of maybe 15 people across Canada. And on the team with me for the particular software installation part, I have my colleagues Maxime Boissonneau, Charles Coulombe, who is here, Doc Roberts, and then for the CVMFS part, we have Ryan Taylor, who's not involved in software installation, but does all the technical parts of CVMFS for us. And so I'm actually employed by McGill, but we work in Quebec with Calcul Quebec, and then at the national level with the Digital Research Alliance. And so, as Dori already mentioned, it used to be Compute Canada, and that merged with a few other organizations to become the Alliance. Charles is also from Calcul Quebec, but not from McGill. I'm not sure where he's at now, because he's moving from Université Laval to Université de Sherbrooke.
Sherbrooke.
Oh, you're already at Sherbrooke, okay. So we basically are a collaboration of all the Canadian national supercomputers, and basically we group together a bunch of national supercomputers. Will be in the next slide, but a big reorganization took place around 2017 era, where we went from basically every research university have their own cluster to having a few, about 5, 6 national clusters, and then some people also have regional clusters, but the main work is done on these national clusters, which all have like a common, very similar interface. And there are now universities that don't have a cluster, but they still have like support staff that then remotely support the clusters. So at the moment, we are going for a renewal here. So basically, we are moving our 6 national systems to newer systems, and it all happens at the same time. You could say, why this timing? That's not my decision. It just happens this way. There's this pros and cons. And so Cedar in, Arbutus is a cloud system on Vancouver Island, and we have Cedar that becomes Fur at SFU. Simon Fraser University, Graham becomes Nibi at University of Waterloo, Niagara becomes Trillium at University of Toronto, and in Montreal we have Beluga that will be replaced by Rocal, and the Norval, which is the one system that actually stays in place. And of course, these newer systems have many more cores per node, so we're moving to almost 1 million cores across Canada, and also a doubling of storage in total. And so the idea was in 2017 that when there would be some research and mobility, so whether they would log into Graham or to Cedar, their interface would be very similar. So if they run their software on Graham and there is some issue with Graham, they can just run it on Cedar instead. They won't have the same priority in the queue, but overall it'll be a very similar interface. So for that, we developed this abstraction layer. So this is where Dori also talked about. So if this design overview of like a layered system, where we have at the top level easy build, so modules like pretty much all HPC clusters use modules, but we have in between the OS and the modules, we have our compatibility layer, which we do via Gen 2. And I'll talk that on the next slide. And then all this software is distributed via CVMFS so that all the clusters in Canada can see that layer. And it's not just the national systems. There are many of the smaller regional systems that also adopted our stack and are using it, and even some systems outside the alliance. I think the government of Canada has used it on a few systems. There are some completely unrelated organizations. Of course, we cannot put everything on CVMFS. There's always stuff that remains on the OS that is privileged or that is very connected to the hardware. And so this is a CVMFS where if you haven't seen this is how it's distributed. So there's a stratum 0 that's like one central server that is then distributed its contents to the strata 1, of which there are multiple ones. In Canada, it's about 5 or 6. And then an individual cluster can cache the contents on a Squid caching proxy, and then from that it gets distributed to client node. So there is a bit of redundancy in there, and also a lot of caching, so that when you reuse some piece of software, it doesn't have to come all the way from the stratum 0. Now, in terms of the Gen 2 prefix, the idea is that we have a base OS from the user point of view that is the same for all the different users. So whether they use CentOS 7 still or not, but if they still do so, or Red Hat 8 or Alma Linux or Rocky Linux or even Ubuntu, they basically have the same compatibility layer, which is all like things that are pretty standard in your average Linux distribution and that are not very scientifically interested. So things that you would not, even on the traditional cluster, you would typically install using RPM or whatnot. We install that in the compatibility layer. And then on top of that, we have things that are really scientific that we install using Easy Build. So that are the programs that are used by researchers like Chromax for molecular dynamics and NAMD and OpenFOAM and whatnot. And there's a whole great variety of software, like bioinformatics was mentioned. That's probably the majority of actual number of packages because it's such a rich ecosystem. And then we have LMOD as the from Tech as the module tool. So here's the idea about how do we decide what should go in Gen 2 or Easy Build. So we have something that is performance critical, does depend on MPI or even OpenMP. There's some Fortran we usually put in an Easy Build, or even if it needs multiple versions, like if for Python, we use Easy Build. On the other hand, for Python packages, like Dori also touched on that, it's like we have most things in Python. The vast majority of Python packages are not loadable via a module, but we have a wheel for that, and maybe I shall want to add a few words here.
So yeah, due to the multiple dependencies, as Dori mentioned in the chat, I think the Python packages are best served in a wheelhouse where the user can manage a virtual environment and just pip install the wheels. And we have a configuration that tells pip, look there, and just prefer our wheels to what you find on PyPy. You can continue, Bart.
Okay. So yeah, then we install it on our build cluster, which we now call Archimedes. It's a cluster in the cloud. It's using Magic Castle. And then we test it, and then we push it to the production repository, and we can see it in the cluster. So this system has been growing over the years. So we're already at basically our third major generation. It started with 2017 and 2020 and now 2023. And so every time we do that, we basically update our compatibility layer with the newer version of the base software. And then we also recompile what's needed in that software stack. So the old stacks are still available. The oldest is now a security warning, but it's still there. And so Dori sort of touched upon, like, what do we then recompile? So we do statistics of which modules are loaded by people, and we work from that. And at the time when we were working on getting standard Env 2023 in place, I basically made like a top 100 of software that wasn't installed yet, and we just worked our way down the list to have like a fairly complete list. And then whatever is missing, the users will email us about, so we can install it ourselves. There's always a large tail in things that aren't much used anymore. So that's pretty much it on my side. I want to take up too much time here.
Great. Thanks so much, Bart. Really appreciate it. So for next, I'll pass it over to Kit Menlove.
Okay, I don't have any slides, but I'll give a brief intro to INL. And I don't know, I see Ben and Scott are on the call, so I don't know how much you guys have discussed INL and what we do here. We're a Department of Energy lab. We focus primarily on nuclear energy, so we do a lot of codes related to DFT and CFD and Monte Carlo, finite element type stuff, a little bit of molecular dynamics. But most of our stuff is currently still CPU based. We do have a growing number of AI applications that are being developed and used here, but they're still kind of in the minority. We have 5 primary systems right now and a 6th one that'll come online this summer. We have Sawtooth, that's about 100,000 cores. Hoodoo, which is our GPU system, it has 108 A100 GPUs. We have a Viz system that's primarily for visualization purposes that has some graphics-centered GPUs in it. And then we have Bitterroot with 43,000 cores and Wind River with 94,000 cores. So currently we're in around 250,000 core CPUs, but we'll be getting another system with 393,000 cores this summer. So that'll more than double our compute capacity in terms of CPUs. And then hopefully a little bit further down the line, we'll get a larger GPU system. Anyway, like Dori said, we have a siloed enclave for HPC for where all of our systems kind of reside in there. We support roughly between 60 and 100 software packages, depending on how you define software packages. But because of the types of software we use, we switched from using EasyBuild about 8 years ago to using SPAC, because the SPAC is developed at Lawrence Livermore, and a lot of the packages that we were supporting were more frequently updated and supported using in SPAC. So most of our software does use SPAC. We do have a fair amount that we hand build. I would say roughly 10 to 15%, and then a growing number of containers that we're trying to build and keep up to date. So we, like Dori had a similar story to what we had here. About 7 years ago, we had 5 folks working on the software facilitation side. And then due to some retirements and a couple people moving elsewhere, we kind of narrowed that down to 2. And now we have, so we had to streamline some of our efforts and kind of make some decisions. Whereas before, people were expecting us to just kind of build whatever they asked, and we kind of had to reduce that a little bit. We support about 1,500 users. About half of those are active at any given time. And like I said, our primary stack, all of our systems currently are on Rocky 8. And we build a lot with SPAC. We use LMOD for all of our modules. For our container modules, most of them have an app tamer exec inside the module. So there's a wrapper there to make it seamless for our users. And then we have a Harbor repository for our containers where users can go and download the ones that we have built in-house. So I think that's kind of a very basic overview.
Excellent. Thanks, Kit. And thank you all for those excellent introductions and context within the systems that you support. So we'll take questions from our audience. However, we do have some questions prepared based on what we've heard from our community with regards to what they're interested in. So the first one is, how does a researcher-driven request for a new software package get handled at your organization? And Bart, I'm going to pick on you first.
Yes. So basically, most software, unless it's something at the foundation, like a compiler and a typical standard env basic ingredient, comes in via a ticket. So across the Alliance, we have a centralized ticket system. So somebody writes a ticket to support at alliancescan.ca or tech.alliancescan.ca, which will get into our ticket system, and then some analyst will help the researcher. And sometimes it's straightforward to install, and if that analyst is part of the RSNT, they can just install it for them and let the user know. When it's a bit more complicated, they create a software installation ticket, which goes in a separate queue in our ticket system, so that we can keep track of it. So basically, the analyst will just tell the user that we're working on it, and then every now and then they'll poke me or one of my colleagues and say, hey, please have a look at the software installation ticket because they're waiting. And then we install it and let the user know that it's installed.
Great. Thanks so much. Kit, could I draw on you to add how INL handle requests for software packages from researchers?
Yeah, it's pretty similar. We get requests from users. Some of them come from through our ticketing system. Some of them people just stop by or email or chat us. If it's a very quick installation, sometimes we'll just say, hey, go ahead and install it in your home directory. If it's something that looks like it might be a little more involved, we ask them to put in a ticket, and then we kind of triage and see how long we think that'll take. If it's something that looks like it'll be a little more challenging, then we ask more questions like, how many users do you expect to use this software? Is it something that is going to be used for a significant period, and is it mission critical? And then from there, we can kind of prioritize it and decide where we're going to put it. So.
Excellent. So it sounds like the ticketing system is fairly standard and then a bit of a triaging process. So how do you choose what software to install centrally as opposed to the researcher's home directory? And Dori, would you mind providing us your perspective?
So in theory, and our policy states that if there are multiple groups that would use the software, we'll install it centrally. What is becoming more practical, though, is we'll help to provide a container for that. We're going to provide everything tool chain and compiler wise and easy build. And then really, unless it's a very large product that we know a lot of people use, like for example, R, we'll install that in our central repository. And we don't do any installations for researchers. We'll give them documentation on how to install in their project directory. And we'll help them through it via a ticket if they run into any problems.
Excellent. And Charles, how does that compare with your folks' practice?
So my thought follows one of Bart, that if the request is most likely to be interest of multiple groups, then we can install it centrally if we have a stable release. Like we focus on installing stable software, not the development version, because those keep evolving, and then we would install it centrally. Otherwise, we can install it locally, help the user to install it locally in their own account. We can provide them with the instructions. But if the software is, let's say, a bit complicated, or there's a few features to turn on for optimization, we can then, if it's easier for the user, we can then install it centrally or just provide them with the instructions to do it.
Yeah, I can also add to Charles that we can give the user an easy build recipe as well. So they basically can use easy build themselves to install it in their home directory, which can be very effective at times.
Right. And then, Bart, there's a user question that came in that I feel you'll have an answer for, which is it's related to Conda. So how do you balance user convenience with computational efficiency, and especially when Conda environments can consume substantial storage and inode resources?
So we are very much against Conda. Like to avoid it where possible. I think, yeah, Dori touched on that. It's like if you absolutely have to use Conda, then use a container or something. But it really is like something of the last resort, because Conda has a nasty habit of, two nasty habits. Which one is that it can take up a lot of inodes in the home directory and just make users run out of quota. And the second is that it sometimes pulls in dependencies that we don't want it to pull in, like sometimes even OpenMPI, which is then not optimized for our system. And then the third thing is that it modifies their bash RC, and they run into unexpected issues in their home directories. I'm just thinking as I go along. So that's why when you go to our documentation wiki and you look up Python, you find a page, and right at the top we warn them, please don't use Conda, use virtual environments, we support you. And of course we cannot stop users using Conda, and people use them, but often when they then ask for support, we have to tell them to please change.
Yeah, 100%.
I think Charles have something to add.
Yeah, of course. So oftentimes when users run into issues, the solution to their issues is not using Conda, and we can help them use the correct modules and set up the environments, the virtual environments, and they get pretty much the same software installed, just from a different path.
Thank you both for that answer. So we have some additional questions from our participants here, but we'll go to another that we collected from our community, which is, what is the most complex software package that you've ever had to install centrally, and why? And Dori, can we start with you?
ANSYS. I hate it with a passion. I lost probably at least a year of my life trying to fight installing ANSYS with EasyBuild, and that includes help from folks from Compute Canada that were kind enough to give us some pointers. We still never quite got it working, but it definitely does seem to be an issue with the newer version of ANSYS. But it definitely caused us to really step back and think about, you know, as system administrators, we've always felt GUIs are not the best use of HPC resources. But when you have users who really need to use something like that or feel they need to use it, you want to let them try and do what you can. And so for 20 years we did that. But as we start getting into some of these packages, like ANSYS is just an absolute beast. Some of the packages work. They certainly work on the command line, but the GUIs don't. And so that made us modify our software policy. So we really do not support installing GUIs. They just don't work well in our environment.
Yeah. Thanks, Dori. Kit, what software package have you had the most interesting adventure with?
Well, I don't know. There's been a number of them. The one that's on the top of my mind right now is actually the XFCE desktop that we're trying to get installed in a local location for use in open on demand. So certainly the GUIs are the ones that have given me the most headache in the past, getting all those dependencies working and making sure all the X stuff works under the hood. There's always some random package that needs to be loaded that the GUI doesn't tell you that's what it needs. You got to go digging. So
let's keep going around on this one. Charles.
So my most pleasure one was probably JaxLib because of Bazel. So Bazel is a fun one. It tries to help you, but I don't feel it actually helps. But then otherwise it would be Open3D. Open3D is a bit like Kit mentioned. It tries to have so many dependencies that you can get lost in there. And it's really nice that some packages have sub-module or, well, when you try to install them, it fetches all the dependencies for you. But once it tries to do that, sometimes it's not reproducible. Someone in the sub package fix an issue, so the next time you build it, you don't have the same, and you try go digging in. Well, it can be a rabbit hole.
Right.
So, yeah, Open3D was very fun.
Sounds it. And then over to you, Bart.
Dori, you have my sympathies about ANSYS. I have not mentioned ANSYS because I mostly outsourced this to Dog, our colleague Dog Roberts, who is very familiar with these commercial packages. But even Dog and I have been in direct Slack messages that went on for weeks to try to debug some GUI. It's a massive headache at times. But yeah, on the other hand, we actually do install like XFCE in the made GUI via Gen 2, and it works surprisingly well. That basically we outsource that to Gen 2 maintainers, and they've done a good job, remarkably, at it. So, but I have to go years back, so I had something similar as Charles in the very early days. This is about 2014 or something. TensorFlow was very, very hard to install, and that I had to nearly give up as well. And it was also related to Bazel, and so I don't envy Charles either with some of these Python wheels at the moment. It was a major breakthrough from easy build community in like 2018 or something that we finally managed easy build to have a recipe to install TensorFlow because it was so tough at the time.
Oh, appreciate hearing those war stories. We have a question from the audience that has quite a bit of support for asking it, so we'll jump right to it. And so this fellow here, Michael Goodridge, is seeing an increased requirement around security. Who here has processes, either automated or human, to perform any sort of validation around the software you're installing? Or maybe I'll broaden that and say what security policies in general yeah, our folks here dealing with security policies with their software installation procedures.
I can jump in a little bit here. We do some, I mean, a lot of our software policies come down to doing scans and regular patching, but we do have regular testing that we do on some of our more critical software packages through Reframe. But that's more on the stability side rather than the security side. So a lot of our security policies come down to who should have access to our export controlled codes. I know a lot of you guys don't deal with those as much, but it comes down to making sure that people who, to siphoning and segregating codes that people should have access to. In terms of our generally available stuff, it more comes down to what we install, making sure that we do our due diligence in checking checksums and making sure that we're validating that the source files that we're getting are not from a questionable source. So a lot of that is just kind of manual, making sure that we have a good process for validating and making sure that we're not installing things that are potentially dangerous.
Excellent. Thank you very much, Kit. All right. So
And then I guess we can mention that we have firewalls and exfiltration stuff on the outside of our enclave to make sure that nothing weird is going on in terms of ingest or exfiltration from the data side either. So
I can add a few things about the security. One thing, like we don't have a formal system, but we do monitor CVEs. Like there's channels within our Alliance Slack where the security alerts, and we monitor the CVEs as they come in. I must say most of the CVEs don't apply to us because they often are about server daemons and kernel root exploits and things like that. So it's just outside our responsibility because we're not responsible for the system software installations, only for the user-facing stack, which is always run as a regular user, so you not run it as root or there's no risk of it escalating because there's no root involved there. Just occasionally it becomes a client-side issue. I think we may remember the XZ or XZ for you Americans issue, which was a very nasty exploit. But fortunately, we had an older version of it that wasn't yet affected. At some point, there was a curl client issue where we had to update the curl client just in case they would use a particular protocol. So we wouldn't be responsible for like users doing things, so they couldn't. It's a lot about blame on the client side. It's like, oh, we didn't install the fixed version, so that if a user makes a mistake because of the security issue, then they cannot blame us for that mistake because we did our due diligence. On the other hand, sometimes, like Dori mentioned, sometimes users have to absolutely use the software that is 12 years old and it's unmaintained. And so, and we cannot stop them really. They can download whatever they want in their home directory and run it, and we can't really stop them doing it. So, but in that case, they cannot blame us for it anyway. So we put a disclaimer on the older stacks, the 2017 based stack, where if they can still load the modules, but we say like, oh, we're not supporting it. There's no security guarantee. So we're basically protecting ourselves a little bit. But eventually we'll have to just make that even more hidden or delete it because we can't maintain that forever.
I appreciate it. I'm hearing a lot about a shared responsibility model where the researcher is ultimately responsible for a lot of the validation, recognizing that they're often the folks with the security agreements. How does that track with your collective understandings?
Yeah, there has to be, because the researcher can do so many things on our system. It's not like like I suppose if you just have an open on-demand system where researchers have a bunch of apps they can choose from, but not able to install their own software, then you can be much more thorough and strict in keeping up. But because we're giving them so much freedom, there has to be some shared responsibility. In terms of process, we have to learn from each other. Like in a sense, is invitation is the sincerest form of flattery. But I mean, like we see CCR and the Easy, they've been modeling their system a bit on us, but we can also learn back from them because they do things sometimes better than us. So it's a really good collaboration here in learning back and see what others are doing about security issues.
Great. So that's kind of the perfect segue to the next question we have, which is, how do you maintain the software that you've installed centrally? So keyword there being maintenance, keeping things updated, etc. And Dori, how do you folks maintain the software stack that you offer?
That's one of our biggest concerns, and kind of why we started having the conversations as we were developing our newest software environment. How do we keep all of this updated? How do we know what software packages are actually being used? Do we have to go out and contact all of the people who requested the first batch of software installations and see if they still want it for the newer version? So those are kind of open questions right now. Obviously, we're updating, we're putting out a new software environment release maybe once a year, once every 18 months. So that includes updated compilers and tool chains and like the base software like R. And then going from there, we're just kind of, for now, we're seeing what people want. Happy to provide them example easy build recipes for them to install themselves. If people want more frequent updates on software, that's where we're going to tell them to install themselves. If they're interested in using containers, what we're doing right now is providing examples of how to build a container, but we're not providing the container itself because we feel like they might feel like then it's our responsibility to keep it updated or our responsibility to troubleshoot it. We just don't have the staffing for that right now. One thing that we're looking into is potentially a container repository. So if we do end up providing that for our users, that is probably where the majority of our software will be, and we'll be able to pull out older containers and put in newer and more updated containers that way.
Excellent. Thanks, Dori. How about on your folks' end, Charles?
Yeah, so we mostly install software through EasyBuild, so centrally and distributed from CVMFS. There's a few exceptions to those, and those are Python wheels, R packages, Perl, and Rust crates. Because there's so many dependencies, we would just be installing modules and new version. So we prefer to let the package manager, let's say pip for Python packages, handle that. And we have a custom build script for the Python wheels. We have some basic configuration through bash scripts where we host all that into a GitHub repository. And then with that, we can build the wheels, provide them through a wheelhouse. And I'll let Bart talk about easy build when you ask him about it.
Oh, perfect. Maybe that's the perfect time
Yeah.
to pass it over to Bart. Anything you'd like to add on the easy build side of things?
Yeah, I mean the updates. I already touched upon that on the initial introduction. Is that we have like a double stream update system. Like we have updated packages within a generation. So there's like Python 3, 10, 11, 12, and 13, for instance, as modules. So the module, when it's installed, it just stays in place unless there's something really nasty that happens that we absolutely, like some security or a major bug that affects everybody, that we have to update it in place. But in place updates are very, very, very rare. And then like every 3 years, we move to a new generation. And so then the default versions also change, and we usually try to change that when there's a new when the researchers get their new allocations for the clusters. So that tends to be in April every year.
Great. Yeah. On to another favorite topic, containers. How do folks approach the method of installation deployment for software? In other words, how do you decide what to provide through a container versus a traditional installation? Kit, how does INL handle this paradigm?
I'll tell you what we currently do. It doesn't mean that that's what we're going to do in the future. Right now, we kind of look at what's available. The first thing we check is it available in SPAC? If it is, then that's typically the easiest way to build it and test it. If it's not available in SPAC, then we might look at things like, is it available in a pre-existing container, like a lot of the NVIDIA containers? If there's something there, then that's typically pretty easy to deploy. Other than that, if it's more something that's a little bit more central to INL and isn't very widely used outside of the community, that the nuclear energy community, then we'll take a strong look at whether a container makes sense, because we want it to be portable across our systems. We want it to be something that we can take forward into future systems. And so we'll look at it and say, what are the requirements of this software? And is it going to be something that makes sense to spend a little bit of time building and testing a container for? A lot of that comes down to the stability of it. Is it a stable code, or is it going to be something that's going to be constantly modified and updated? What are the types of things that this user is going to use while he's using this software? Are there a lot of plugins or other things other utilities that they use at the same time within the same job script that would make using a single container more difficult to build or utilize? And so we just kind of look at it at a high level and say, does this make sense to put in a container right now? And oftentimes the answer is yes, but sometimes it doesn't really make as much sense because of all the intertwined dependencies on other things. And then there's also a side case where there's one code that we thought about containerizing, but then we looked at the usage, and it very frequently goes above our 4 gigabytes per core standard on our compute nodes. And so having a large container in RAM on top of this application, which already uses a lot of RAM, didn't make sense in that case. So that's another thing that we consider.
All right. Who else would like to offer a perspective on containers as perhaps one of our final thoughts?
Yeah, I have something useful to say. We have since a year or two our container repository as well on CVMFS. It's actually an open repository that anybody can mount, called CVMFS containers.computecanada.ca. And we only have a few packages in there, if I remember. I need to go to my notes. So yes, so we have 3 packages: Deep Variant, Queen 2, and fMRI Prep, and those packages are full of dependencies, and it would be such an enormous amount of work to install it all manually, not just the software itself, but all the dependencies, that you literally run into hundreds of them that often need a very specific version. And that will be so time consuming that we just say, okay, there's not much performance benefit of compiling it ourselves. We just take the container from them, we unpack it into our CVMFS, and people can use that via Obtainer. and it just saves us so much time and gets the researcher exactly what the developers intended it to be as well. So it's like the developers compiled it, and they'll get the results that developers expect. And so far, it's that proved to be much easier for that kind of software.
Excellent. Well, we're almost at the, oh, go ahead,
Matt,
Dori.
I just want to bring up one thing.
Please do.
When we started developing our framework for software, we were looking at Compute Canada, and I put in the Slack too about Easy. Both of them offer these CVMFS repositories. They're read-only. It's where the software, or like Bart said, the container is published. And you can mount these CVMFS repositories like a file system on your own HPC center. So for those of you who aren't yet automating builds, test this out. We did. We mounted the Compute Canada CVMFS repository and just tested how do we module load? How do we install new software? And we at CCR don't offer the ability to use ours yet. We probably don't. We don't have anywhere near the amount of software that Alliance Canada and Easy has. So definitely look into those and check it out, because it can be very easy to just all of a sudden have 10,000 software packages available.
Yeah, and it's the same. Like
Jesus.
I've just been to an Easy Build user meeting where we were mounting Easy on one of our clusters, and they had some workshop where we could do run their test suite, and so I can also run their test suite to see if it works well on our cluster. So there's a lot of cross collaboration that can happen because of CVMFS having this publicly available.
Excellent. Kit, last word?
I was just going to say there's a similar feature. I guess it's not exactly the same, but SPAC has a pretty large and growing binary cache as well. So as you're building your software, you don't necessarily have to build it all from scratch. A lot of that can be downloaded from SPAC's binary cache. And there's also an upstream feature that we've given to some of our users where they can put a little config file in their local SPAC installation and leverage all of the SPAC stuff that we have built at the central location and be able to build and leverage that fairly easily for any other SPAC builds they want to do, leveraging what we've already done. So there's some pretty good tools out there available.
Great. Thank you very much, all. What a perfect way to end this panel. Thank you, everyone, for your attendance. A huge thanks to our panel for taking the time today and handling our questions. This is clearly a topic that was very interesting to the community. Love seeing the chat activity as well. So thank you all, and have a great day.